So one more addition to the UML is the component diagrams, and the main purpose of this component diagram is to show the breakdown of a large system. So if you want to represent your system into smaller subsystems or components, you can use the component classifier. So component classifier will be a different type of rectangle, like a class specifier we used to see in the previous models of the UML. So we can use that component classifier for representing a component of our system. The functionality provided by a component is specified by a set of provided interfaces that component actually implements and provides. In addition to providing interfaces, a component may require interfaces in order to function. So there is a possibility that a component A provides a few functions. Okay, so let's suppose a calculator component provides the interface for addition, subtraction, multiplication and division, but at the same time that calculator component might require other interfaces to function properly. So let's suppose that calculator cannot calculate a text. So to calculate the text, it uses an interface of another text calculator component and provides its complete functionality. And please keep this in mind that components actually provide their functionality with the help of their internal details and their internal classifiers. And the internal view of the components is composed of classes. So exactly, the components are a combination of classes where these classes are depending on each other, they are inherited or encapsulated in each other, and then the complete component is providing its whole functionality. So the component diagram actually describes the software components and their dependencies to each other. So whenever you are having the dependency and communication between different components of your system, that can be represented with the help of the component diagrams. So guys, this is one of the examples of the component diagram where we have the UML viewer component. This UML viewer component is like UML viewer.exe. Please do not forget that this UML viewer.exe is going to have a number of classes inside it which are providing or making this a complete component. And in return, this application component, which is the UML viewer.exe, is using some other subsystems like command handler, like the database handler and the graphics. So these are three different DLLs, or you can say some other group of classes which are being used by this application. So for showing that these components are placed or they are part of one package, I can use this notation from the package, and then inside this package I can show the different components interacting with each other. As there is a separate and complete discipline and area of research called component-based software engineering, but just to understand the concept of components analogically, you can consider your home entertainment system. So you know that in your home entertainment system, you expect that you can easily replace the DVD player or speakers. So if you want to upgrade the speakers, it will not affect the working or functionality of the DVD players, and if you want to change your DVD player, it will not affect the performance or any major impact on your LED TV. So this is how we are actually working in a modular, self-contained and replaceable fashion, so that we can get benefit of the components. So for example, at a large gained level, a SQL database engine can be modeled as a component. So any database that understands the same version of the SQL language, it can support the same transaction semantics, it can execute the same queries, and it can return and generate the same results. And if we want to see this in action at our application level, we can see any solution that implements, let's suppose, the Java Messaging Services API. So that Java Messaging Services API can be used or replaced in any system. So JMS is a standard messaging for use in the application, and with the help of that we can create, send and receive and read the messages between different classes and objects. So it enables the distributed communication, which is very loosely coupled, reliable and asynchronous. So by distributed we mean that these objects are placed at different geographical positions and still they can communicate with each other. So as we are using the components for getting the benefit, like having the replaceable parts and still having not effect on the overall functionality, there are some general guidelines which we must follow. It says that do component modeling for relatively large scale elements. So if you want to distribute your system into components, make sure that you are having a relatively large scale elements and you are making them into smaller components, because it is very difficult to think about a design for many small fine-grained parts. So instead, whenever you're having a very small portions like a program of your assignment, which is a very small in length and size, you might not be able to think of components at that stage. But if you are thinking of a big application like Microsoft Word, you can think of a component like the grammar and spell checking component. Now that grammar and spell checking component can simply be replaced or maybe reused at some other later versions of the Microsoft Word or some other similar text editors. So as we have previously seen this ball and socket notation, so to represent the dependency of this next generation point of sale system on this messaging service, we can use this ball and socket notation here. So this represents that our next generation point of sale system is using or is dependent on the messaging service. And in addition, this small notation or icon here represents that this Java messaging service here is actually a component. And then we can have another alternative notation for representing a component, which is stereotype notation. So with the help of this stereotype notation, using those, remember those guillemets, we can represent our database component, an independent database component here in this rectangle. And to show the dependency, we can show that this next generation point of sale system is also depending or interacting with the SQL component. And for more theoretical details, you can go and read chapter number 38 from Applying UML and Patterns. Good luck!